equation of the curve y is equal to f of x with the equation of curve, then here, yeah, this is the given curve, right? On the curve, I'm going to take a point p of x comma y is any point, or x1 y1. You can take p of x1 y1 is any point on the curve. Then at that point, I want to find the tangent and normal. So at that point p of x1 y1, how many tangent can be drawn? We can draw only one tangent. Only one tangent is exist. Yeah, let us take this as the tangent. Then what about the normal? Normal always perpendicular to the tangent. Okay, normal always perpendicular to the tangent. Clear, students? The angle between normal and the tangent is always 90. So both will be perpendicular to each other. See here it is I'm taking, this is capital T. Capital T is a tangent. Capital N is a normal. Okay. How can you find the equation of tangent and normal? This is clearly origin. So before finding tangent, we should find the slope at that point. Here we are having only one point, x1, y1. How can you find the slope? To find the slope, different methods are there. When they give an angle theta, when they give an angle theta, we can find the slope easily, right? So every line can make an angle with x-axis, positive direction of x-axis, right? Let us take this is theta. When theta value is given, the slope is given by m is equal to tan theta. Fine. If they give any 2 points, otherwise instead of theta, if they given any 2 points on the given tangent, like here one point is I'm taking as, here it is x1 y1, another point somewhere here x2 y2. Otherwise p, this point p you can take as x1 y1, this point I'm taking as q is x2 y2. Then in this case the slope is given by that, you know very well, y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1, right? Then in that case, what is the equation of the tangent? So m can be written as dy by dx. M also can be written as f dash of x. M is dy by dx, or else simply write as f dash of x, right? Now here I want to know the equation of tangent when theta is given. When theta is given, then with the help of tan theta, first find slope, and the point will be there x1 y1. Can anyone tell that what is the equation of line which is passing through the point x1 y1, whose slope is m? That already studied in straight line.
Equal to m into x minus x.
Y minus y1 is equal to m into x minus x1. M into x minus x1. Fine. Here when they given theta, I told you that with help of tan theta you can find dy by dx. Nothing but this is also can be written as dy by dx x minus x1. Okay, you can remember here any one of the formula. Better to remember second one. Okay, so you better to remember the second one here. Fine. So this is the equation of tangent. Okay, student, for example, theta value is not given, just a point alone they given. Point alone they given. Then how can you find the dy by dx? How can you find dy by dx? Simple. For example, just find dy by dx with alpha. They given like y is equal to x square, and point they given something they given 1, 2. I'm taking the point is 1 comma 2 here, p of x1 y1 as 1 comma 2, and equation of the curve I'm taking as y is equal to x square. I want to find the tangent at 1 comma 2. Tangent to the given curve y is equal to x square at 1 comma 2. How can you find the tangent equation? Okay, point is given 1 comma 2. We may write y minus, this is x1, this is y1, y minus y1. So y minus 2 is equal to m into x minus x1 means 1. How can you find m here? They did not given theta. Okay, but we need to find m further simple. But they given curve, equation of curve, that is y is equal to x square. Now differentiate. Then find dy by dx, that is equal to, we get 2x. Now this dy by dx, you can find at x comma y, that is given point 1 comma 2. Substitute in place of x1 in place of y2. Just we having only 2x, 2 into 1, that is equal to 2. This is dy by dx, nothing but m. So very simple, student. So if they given any point and if they ask the tangent equation which is passing through the point x1 y1 is given by this formula, or you can remember this formula. So whenever m is not given, just differentiate given curve, find dy by dx. So after finding that, you can substitute the given point in place of x, in place of y. So you are going to get dy by dx as a numerical value. Remember that slope always a numerical value. It should not be a variable, right? Okay, so here we got dy by dx as 2. Okay, and we know that the x1 y1 has 1 comma 2. Substitute here, you are going to get tangent equation. Find this is a tangent. Okay, the slope of the tangent I want to take as m1. Take slope of the tangent is m1. Here the equation we are going to get y minus y1 is equal to m1 into x minus x1. But what about the equation of normal? Normal also a line, every line having a slope. I'm taking slope of normal as m2, and since we know that the angle between tangent and normal will be 90 when two lines are perpendicular, that we know very well, the product of their slopes is clearly equal to what? m1 into m2 is equal to what always?
-1.
-1. Okay. Okay, with help of this derivative dy by dx, here we got m nothing but m1. So when you find the dy by dx will give the slope of tangent alone, not normal. Okay, here we got dy by dx at 1 comma 2 as 2. I'm taking as m1, then m2 value. Okay, is it possible to find the slope of normal? Yes, m2 is equal to -1 by m1. So m2 value is -1 by m1. m1 already we got as 2, so -1 by 2. So slope of the normal will be -1 by 2. So what we can remember here, when the slope of the tangent is k, the slope of the normal is -1 by k. If slope of the tangent is 100, slope of the normal is -1 by 100. If slope of the normal is 1000, slope of tangent is same, -1 by 1000. Okay. For example, slope of the tangent is -1 by 10. Slope of the tangent -1 by 10. What is the slope of normal? -1 by 10 becomes, right, if reciprocal, opposite side. 1 by 10 becomes 10. -1 by 10 I said, you simply can take plus 10. That's all. Okay, so here the normal equation, this is the equation of tangent. Then the this is equation of tangent. I'm going to explain you more briefly. So this is starting class. Just I'm giving some overview of tangent and normal and some idea about tangent and normal, right? The questions are very easy. The questions are based on only two formulas. One is tangent, one is normal in a particular exercise, right? Now I'm going to write the equation of normal here. Equation of normal is y minus same. How can you find the equation of normal here, which is passing through the point x1 y1? Same, y minus y1. Normal is also a line, since we know that its slope is minus 1 by m1. Shall I write? So first you can write m2, because m2 be the slope of normal x minus x1. Y minus y1 is equal to m1, m2 nothing but 1 minus 1 by m1 into x minus x1. And also if you want to write in terms of dy by dx, minus 1 by dy by dx. Okay, what is m1 here? m1 clearly dy by dx. Dy by dx, that alone I have replaced into x minus x1. Or else see, any one of the formula you have to remember, that's enough. Minus dx by dy into x minus x1. So these are the formulas for equation of normal. Okay, equation of normal. Clear, students? These are the formulas of normal. So it's try to remember this second formula and third formula. Second and third formula. That's enough. Okay, students? Second and third. That's enough. Simple, right? Now, when they given any point, the tangent equation is y minus y1 is equal to dy by dx into x minus x1. Then this is normal equation. Before that, already you know very well the tangent which is parallel to x-axis. Yes, student. If the tangent is parallel to x-axis, then what about the slope of that line number? If I take line is, yeah,
0.
yeah, it's surely it is 0. If the tangent is parallel to y-axis, then parallel to y-axis. Yes, students. Parallel to y-axis, parallel to x-axis. Because we can remember the slope in two ways, because slopes are very important. If you see that here in one particular exercise which is belongs to tangent and normal. So the questions which is related to slope and tangent normal, only three questions. One is slope, one is tangent, another one is normal. Right, look at your first question, find the slope. Find the slope of the tangent. Slope nothing but that we know that m is equal to dy by dx. But particularly they given x is equal to 4. Find dy by dx. What is the dy by dx, Amma? It's simple. 3x power 4 is there. Shall I write 12x cube? 3x power 4 derivative is 12x cube. Minus 4x is minus 4. Yeah, after finding dy by dx is a m slope. Then substitute x is equal to 4. 12 into 4 cube minus 4. Simplify this. This is the answer for first question. Second question is what? Again, tangent. Again, y is given, just to find dy by dx. Right side is u by v rule. Find dy by dx, substitute x is equal to 10. That's all. You'll get again m value. Third question, find the slope of the curve. at whose x coordinate is. See, indirectly they given x coordinate nothing but x is equal to 2. Understood? Previous questions, they given x is equal to 4, x is equal to 10, but here it is x coordinate is 2. Nothing but x coordinate always x. Okay, so here dy by dx clearly 3x square minus 1. Yeah, x is equal to 2, you can substitute here. This dy by dx is the slope, so m is equal to 3 into 2 square, that is 12 minus 1, that is 11. That's all. I'll explain you once again, but I'm giving some idea to do this. Fourth question also, find the slope of the tangent. Once again, I'll explain you, nothing to worry, right? Find the slope of the tangent to the curve. Again what? Again find dy by dx. Dy by dx is 3x square minus 3, that's all. But slope always I said the numerical value, whose x coordinate is 3. X coordinate nothing but x is equal to 3, you can substitute. That's all. That is slope. Fifth question, find the slope of normal to this at theta is equal to. See here, question number 5, what they given. So it is related to parametric. Already we have done in chapter 5. Only the thing is, if you want to understand these applications of derivative, you must complete idea about that fifth chapter. Because we have done differentiated many questions, like many types, like logarithmic method. This is a parametric form, and we applied like second derivatives. Okay. So we differentiated inverse trigonometric function, everything we have done. But compared to that chapter 5, these questions are very easy to differentiate. They'll give very easy question to differentiate. But the thing is, so we have to, like, only the difficult exercise in this chapter is maxima minima. Only maxima minima, and that only few questions are difficult. Difficult in the sense it will take 1 or 2 pages, or sometimes 1 or 2 questions, 3 pages also. Other than that, it is very simple to find that. So here, what to do actually in this question, fifth question, x is given, find dx by dt. Okay, y is given, find dy by dt. At last here, slope of normal they are asking. First find dy by dx. They may ask slope of normal or slope of tangent, whatever they ask. First find dy by dx. Okay, so dy by dx is given by here. It can be written as dy by dt and dx by dt. That's all. You'll get dy by dx. This dy by dx I'm taking as m1. And I told you clearly, dy by dx always slope of tangent. Always slope of tangent. But the question is slope of normal. So m2 is equal to minus 1 by m1. m2 means slope of normal. Slope of normal is equal to minus 1 by slope of tangent. Okay, here if you find dx by dt, you'll get the value in terms of theta. You can substitute theta value pi by 4 here. We get a numerical value. Okay, so if you get doubt, see here, x is equal to a cos cube theta is there. What is dx by dt? A into cos cube, in the sense chain rule, apply chain rule, 3 cos square theta. First x cube is 3x square into cos theta derivative is minus sin theta. Okay, but this value dx by dt we required at theta is equal to pi by 4. Now dx by d theta at x is equal to pi by 4. So theta is equal to pi by 4 means a into 3 cos square pi by 4. Cos square pi by 4, cos 45 1 by root 2 whole square into a minus, you can take it outside, sin theta, sin pi by 4 1 by root 2. That's all. This is dx by dt in a numerical value. Like in the same way dy by dt, then at last dy by dt by dx by dt will give you. So question is easy. Next, find the slope of the normal to the curve. Same again parametric equation. Find dx by dt and dy by d theta d theta dx by d theta, dy by d theta, after that dy by dx with the help of this formula. Okay, that's all. Substitute here theta is equal to 90. And coming to find the points of the curve. See how logically question they'll give. Very logical applications. Here it is. It's not like general pressure, okay, differentiate, apply some formulas, not like that. It is we have to think, like we have to analyze that what is the question they given, then what to do. See here, it is a simple question. What they given here, find the points. Okay, that we need to find the points. That is, you can leave that. Find the points means we'll find the points. For that, what is the condition they given? The tangent of the curve is parallel to x-axis. Parallel to x-axis, just now we discussed here. What I asked that here, the tangent which is parallel to x-axis, then what is the slope? I asked. So these conditions are important. See here, on the x-axis, theta value always 0. On the x-axis, theta value 0. Then when theta value is 0, I already explained this. M is equal to tan theta. So M is equal to tan theta means tan 0. So tan 0 is 0. So x-axis slope is 0. X-axis slope is 0. And when two lines are parallel, that we know very well, their slopes are equal. Their slopes are equal or not? Their slopes are equal. This line is parallel to x-axis. Then what is the slope of this line? Also 0. The line which is parallel to x-axis, then its slope becomes always 0. Okay, coming to, this is one way. Then coming to here, what is the slope of the line which is parallel to y-axis? Before that, we have to find the slope of y-axis. Now, what is the angle between x and y-axis? Yes, y-axis can make an angle 90 with x-axis. So tan theta here, angle between x and y-axis is 90. So m is equal to infinity. So is it the tangent slope is defined for y-axis? What is the slope amount? Infinity. Is it defined? Undefined. So slope of y-axis is undefined. The line which is parallel to y-axis slope is what? Slope of y-axis is infinity. What about this parallel line? Students. The line which is parallel to y-axis is what? Infinity. Slope is infinity. Okay, this is one way to find the slope. Another way is if they given any 2 points on x-axis. Let us see here. If you take any 2 points, the line which is parallel to x-axis, simply student, what about this point amount? Parallel to x-axis. You can take x1, y1 like that only. But when you observe here, both the cases, can I take this is x1 comma y1. This is point is x2 comma y2. Okay, what do you observe, students, here?
y1 is equal to y2.
Exactly. Y1 is equal to y2. When the line parallel to x-axis, y1 is equal to y2. x1, x2 are different here. x1 should not equal to x2, but y1 is equal to y2. Since when they given 2 points, x1, y1, x2, y2, then tan theta formula is what? For slope formula is what? Not tan theta. M. Already is to y2 minus x2 minus x1. That is y2 minus y1. y1 is equal to y2, so that 0 by here x2 not equal to x1, so that it is not equal to 0. x2 minus x1 only will get. So what? 0 by anything is 0. So that your slope of the line which is parallel to x-axis is 0. In the same way, when you see that the line which is parallel to then y-axis, this is like I'm taking one point here, x1 y1, this is x2 y2. In that case, what? In this case, clearly x1 is equal to x2, but y1 not equal to y2 because it is parallel to y-axis. In that case, again same tan, not tan theta, again m is equal to formula y2 minus y1 by x2 minus x1. So y2, y1 not equal to y2, so that y2 minus y1 should not equal to 0. So numerator should not equal to 0, but denominator is 0. So numerator not equal to 0, some value is there. So something by 0 is what? Infinity or undefined. So that in this case also we said that, so both will be like the tangent which is parallel to y-axis, means slope is does not exist. Slope is doesn't exist. So here in this question, what to do here? Already just now I explained that the tangent which is parallel to x-axis, always slope is equal to 0. Slope nothing but dy by dx. Remember that slope is either you can write m or else dy by dx. In this chapter, in this exercise, try to write slope is dy by dx. Okay, see here, student, the tangent to the curve is parallel to x-axis. Parallel to x-axis means what to do here? Just find dy by dx. You are going to get some dy by dx 3x square minus 6x minus 9. Okay, ma, can you tell me here? Clearly, they given the tangent is parallel to x-axis. What is the slope, ma? Slope. This dy by dx is slope of given curve. This dy by dx means 3x square minus 6x minus 9. The slope of given curve. This slope is clearly, yeah, what about this is equal to? It is clearly parallel to x-axis. No, this is equal to 0. That's all. If they don't give this parallel to x-axis, we should not equate that dy by dx is equal to 0. When we equating to 0, it is a quadratic equation. Am I right? We are going to get some x values. So 3x square minus 3 is common, means x square minus 2x minus 3 is equal to 0. You are getting some x values. What are the x values in this case? I think minus 3, 1 means 3 comma minus 1. Am I right? Yes or no? 3 comma. Am I right? Okay, let us assume this is 3 comma minus 1. This 3 value you can substitute in given y. They are asking points. Points nothing but x value and y value. We got x value. This x value substitute over here. We'll get y value. Substitute x is equal to minus 1. You get another value. So finally we are going to get 2.3 comma something. Minus 1 comma something. These are the required points here. Required points. Okay. So if you understood any, like if you understood here something, then try to do the problems. All are very easy. Almost all questions are parallel to C here, parallel to x-axis, and some almost a few questions are they parallel to x-axis, parallel to y-axis. Okay, like that. Parallel to y-axis, parallel to x-axis. Okay, I'll explain you all the questions. All are very easy. And remember that there is no relation between 6.2 and 6.3 like that. Okay, so application no relation. Even if you start directly 6.3 also no problem at all. It's not like a function. If you have function, if you understood that the 1 function onto function, then only we will discuss about inverse function. We cannot start directly inverse of a function. But here in application not like that, we can start any topic. These are the just applications, different applications. Okay. I hope that you should remember the equation of tangent very easy, straight line equation alone. Slope point form. Already you studied in class 7. This is slope, this is point. Slope point form is give directly equation of, sorry, this is tangent alone. This is a point, this is a slope. Slope point form. So when we find the slope of the tangent, finding normal is very easy. In slope, here m1 coming to normal is minus 1 by m1. That's all. Point will be same. Slope alone will be changed. So entire exercise is very easy and very important here. The important exercises are maximum minimum first, tangent and normal second, increasing, decreasing. Then after we'll go for approximations,